Hello there, 111 students. This is a brief as can be video regarding your molarity problems, okay? Molarity is really important. You will really get to do the molarity whenever you take a chemistry class, if that applies to you. When you go into A&P, if that applies to you, you learn osmols, and so we won't be doing molality, so don't worry about that. But I'm going to show you how to do your lab 4 molarity problem in addition to a couple of other small snippet problems. That way you can have some practice, all right? So, first thing, molarity. What molarity is, it's a measurement of the amount of essentially molecules or atoms within a solution. So if you make yourself a solution, like we did in lab, we used our copper sulfate crystals. We used those and put them together with the water to make copper sulfate pentahydrate. We made a 1 molar solution. And how we know we made a 1 molar solution, it had to do with the ratio measurement of the actual copper sulfate crystals in comparison to the water in which it was dissolved in, okay? So that is the overall general premise. When you get into chemistry, you get to talk about Avogadro's number and you get to do more calculations. If you have done this, that is awesome. I'm not gonna require this from you. We're gonna try to KISS. We're gonna keep it simple, sis, okay? All righty. So, molarity. There's a formula. Molarity, which is termed big M, equals moles of solute divided by liters of solution. Okay, so moles of solute. The solute are all of the small little cute little particles that are dissolved in the water. So I'm actually going to draw it over here, but then I'm going to erase it. So if you have a beaker, let's pretend we did our copper juice, okay? Remember, you dissolved your copper crystals, just like such, and you dissolved them in water. That is what you did. Copper crystals, the blue, dissolved in water. There you go. So when we're talking about the moles of solute, the solute are all the small little dissolved particles, okay? So, solute. The small blue dissolved particles, the molecules, the atoms. So I always say, you know it's solute because it's the smaller portion of it. You have a lot more dissolving liquid than you do the particles. So with that, solute is cute. Cute. There you go. Look at those cute little tiny dissolved particles, okay? That's how I remember solutes are cute. The dissolving liquid is called a solvent. Solvent. So the solvent is whatever you dissolved it with. Most of the time, and especially in biological systems, the solvent is water, okay? So put it together. We'll go ahead and top them up. The solute dissolved in the solvent is termed the solution. So I can't do it over there. Solution. The solute, the dissolving liquid, the solvent is the solution to the whole problem. So put them together. Let's go ahead and put dissolving liquid. All right, wonderful. Now we can go ahead and put our terminology. Solute, boom, liters of solution. That's the whole thing, okay? So we want to figure out the molarity. It's a measurement of those molecules and atoms that make up the solvent, that make up the moles of solute per liters of solution. Alrighty, so when you're doing your molarity problems, I say put that at the top of your paper at all times. keep referring to it, okay? We have some measurements that we want to keep looking at. Alrighty, so you are supposed to figure out what the molar mass, I'm basically looking at your lab, page 2. First step was to figure out the molar mass of copper sulfate pentahydrate. So that's what we're gonna do. Excuse me, you know my thing. All right, so let's go over here, molar mass. So I'm gonna go ahead and write up. By the way, I'm gonna block this off. Not using it yet, but I will be using it. So copper sulfate pentahydrate, CuSO4, 5, there's a dot because there's time, it's a 5, H2O. What that means is there are 4 atoms of oxygen, 1 atom of sulfur, and 1 atom of copper. Look at over here. In a water molecule, there are 2 atoms of hydrogen and 1 atom of oxygen. But essentially, that's what that means, that there are 5 water molecules, okay? So now that you see that, I'm going to take that away. So what we want to figure out, we want to figure out the molar mass. So what the molar mass is, it's going to be the equivalent of all of the mass of every single atom. So let's go ahead and write this. You're going to need your periodic table too. So I'm going to go ahead and write this down, copper, and you actually have this, you already have this to be tabulated, you just got to fill in the answers in your lab. So you got copper, you got sulfur, oxygen, hydrogens, and more oxygen, okay? So your copper, we just have 1 atom of copper. But what we need to do is we need to look at our periodic table and we need to find the mass of the copper. I didn't have a periodic table out. What was I thinking? Let me go to the internet because they have plenty of them there. Let's see. I have one on the wall in class, but it's on the back wall. So, nice little periodic table. We want to find the atomic mass. That's not a good one. I can't see that one. Let's find one that we can see. There we go. That should be good. There's so many variations. I just want the plain one. That's all I care about. There we go. Copper. Copper has the atomic number of 29. So you can find it in the periodic table, the atomic number 29. But if you look at the larger number that is underneath the Cu, that is the atomic mass. The atomic mass is going to be approximated by the mass number. And so that mass number approximation is equal to protons plus neutrons. That is the number of those protons and neutrons that are in the atomic nucleus. So your atomic mass, or i.e. your mass number for copper, is 63.546. So equals 63.546. We don't need so much. So how about we call it 63.5. There you go. I'll go ahead and keep it like that for now. Alrighty, so your sulfur. Oh, by the way, there's only 1 atom. So let's just go ahead and finish this. Times 1 equal, and we really shouldn't be doing x's. We should have lost that a while back. 63.55. All right, sulfur. See if we can move this party around a little faster now. It's number 16 as far as the atomic number. The atomic mass is 32.066. 32.066. We're going to go ahead and round that to 32.07. We only have 1 atom of it times 1 atom equals 32.07. All right, oxygen. Oxygen is 15.99. We go ahead and round that to 16.00. See how many atoms of oxygen we have. Go ahead and get some brackets for times. We have 4 atoms of oxygen here, but we also, and a water molecule has 1 atom of oxygen, but we have 5 molecules of water. So 5 times 1 is 5. So those 5 plus those 4 is the number 9. There are 9 atoms of oxygen. I'll get the calculator out all at once. Alrighty, so your hydrogen. We're looking at, we got that covered, got it covered. Sometimes I'll go like this to kind of keep, so I can kind of keep track. You don't have to do that. So there are 2 atoms of hydrogen within 1 water molecule. There are 5 water molecules, so 5 times 2 is 10. Hydrogen is 1.0 blankety blank blank blank, and it rounds to 1.01. So we're going to call it 1.01. And how many do we have? We said we had 10 of them. Make sure I counted for them all. Yeah, sure did. 10 of them. Alrighty. So let's go ahead and calculate that first one. We've got 16 times 9. Feel free to do the work with me. 144.00. That's what it came out to. Okay, so 1.01 times 10 should be 10. Let's see if my brain likes that today. 10 times 1.01. I'm going to tell you, I verify everything. Yeah, 10. All right, so we're going to go ahead and add those together so we can get all of those equivalent masses together. All right, so 5, 7, 13, 0, 0. Add it, so 5, 6, 0, 0 is 7. If I mess up on my math, I don't have anybody to tell me, so hopefully I do well. All right, so you got 3 and 2 is 5, 6, 7, 8, 9, and a 0. And then we have 6 and 3 is 9, plus 4, plus 1, so that's 10, 14. Add that one there. Nothing there, nothing there. 2 of them, nothing there. 249.73, okay? So you need to have a label. Everything has to have a label. You can't ignore it just because you don't like it or not sure what it is, okay? That's real stuff. All right, so with that, our label is gonna be grams per mole. That's part of our label, so let's start with that. Grams per mole, okay? Well, we need to finish it off. Grams per mole of what? It could be grams per mole of sugar. It could be grams per mole of salt. It could be grams per mole of anything, okay? So it's grams per mole of copper sulfate pentahydrate. You have to put that. If you do not put that on your lab practical, it will be incorrect because it doesn't tell me anything. It tells me a number, but it doesn't tell me what the number is for. So, grams per mole, CuSO4, 5H2O. Alrighty, I like to box my answers because that's what somebody made me do a long time ago. Helps me to stay focused. I work all my steps. Alrighty, so with that, that was our first step to figure out the molar mass. This is the molar mass. I'm going to erase this. I'm going to show you what exactly does that mean when I'm telling you grams per mole of copper sulfate pentahydrate. You are going to use this to make yourself a conversion factor, okay? Which is why I started you on conversion factors the last week. So this is saying the same thing. Watch me. 200, oh, that's a terrible move. Let's try again. 249.73 grams of CuSO4 5H2O per 1 mole of CuSO4 5H2O. That's a conversion factor. That is what that equates to. Now, why is that important? Because you are going to use it in your calculations to basically what I told you before, chase labels and to get to the correct answer. Guess what? It won't always be in that fashion. Sometimes it could be in this fashion. 1 mole of CuSO4 5H2O is equivalent to 249.73 grams per, grams CuSO4 5H2O. There you go. So with that, depending on how it needs to be used, it could be like this, or it could be flipped like this. No matter what, it doesn't matter, because 1 mole equals that many grams, and that many grams equals 1 mole. It's the same thing. It is just flipped depending on how you need to manipulate it to do your calculations. All right, so now that you have that, you can always rewind videos you need to. I'm going to go ahead and erase this right here. I'm going to keep that for now. Let's go ahead and call up that lab paper again, if I can find it. There we go. All right, so the whole point is we wanted to figure out what we needed to use for lab, okay? So on page 3, it talks about the calculations. So I'm gonna go ahead and read page 3. We need to figure out some things. We need to figure out how many liters in solution, how many moles. We need to figure out some stuff. So I'm reading on page 3, and it talks about the calculations. It says, and it's highlighted in yellow, using the molecular mass determined, using the molecular mass determined in the molecular mass section, right there, how many grams of CuSO4 are needed to make a 1 mole solution, molarity solution? Because here's the deal, molarity and mole are not the same thing. This is how much solute, this is how much solute per liquid. Sorry, just needed to back that up so you can see. So I'm looking at your calculation going through here. What do we know? We know this right here, molarity, moles of solute per liter. Now, if you look at our molar mass, we could see some things. Number one, the question wants to know how many grams. When you look at this, look at that. This says something about grams, but this says moles. Go back to our other calculation. That doesn't say grams, but it says moles. So I could use that formula and input information from that formula to here to change moles into grams. Okay, so that's going to be our objective. So what are some things that we know? Some things that we know is they want to know, looking at, like I told you, page 3, where it says calculations and the highlighted part. I'm going to read it again. Using the molecular mass, how many grams of CuSO4 5H2O is needed to make a 1 molar solution. All right, so let's start writing down some things. We're looking for a 1 molar solution. So 1 molar solution, CuSO4 5H2O. That's one of our objectives. So I'm going to write one of our objectives down. And then it says to follow in a 1 liter solution. Well, look at that. We got liters here. So I'm going to go ahead and write this down. 1 liter CuSO4 5H2O solution. Okay, solution. Boom, check. Well, now look at this. I have this, check, boom. I have this, check, boom. If I have 2 of the 3 variables, I can use these to figure out that. So that's going to be our first thing. All right, so it's real easy. I'll just be honest with you, 1 and 1, it's going to be 1, okay? But will it always be that way? No, it won't. So I need to show you the math, okay? So by showing you the math, I'm going to show you how to chase your labels. All right, and I get it. You already did it in your head, you already got the answer. I got you. So let's go ahead and write it out. So I always write it out, molarity. Molarity equals moles of solute divided by liters of solution. Okay. Now, my molarity is going to be 0.1 mole. Boom, erase it up. So, it's not 0.1, excuse me, 1 molar solution of CuSO4 5H2O solution. Look at this. This is equivalent to being over 1. Hope you recognize that. It's equivalent to being over 1. Okay? Alrighty, so I'm going to take that away. Now, what else do we know? Liters of solution. Let's go ahead and input what we know. 1 liter of CuSO4 5H2O solution. Boom. So calculate it. You have to isolate this variable by itself in order to solve for it. So this is your algebra. So it might be that you would need to hone up on your algebra skills. So you do it on your own. I'm gonna go ahead and do it up here. If you don't like the way I do it, don't argue with me. There's several different ways to do it. I'm gonna do it the way I feel comfortable doing it and has never steered me wrong, okay? Alrighty, so I'm gonna get rid of this. I'm gonna times it by that. I need to erase one of these. I'm gonna erase the one on the top because I need that room. Okay? So I wanna get rid of the one on the bottom, so I'm gonna times it by that. If you cross multiply, that's fine, however you want to do it, okay? So I times it by 1 liter CuSO4 by H2O solution. There you go. You cancel and you cancel. Why? The 1 is the same, the liter is the same, the copper sulfate solution is the same. You cancel it. But whatever you do to this side of the equal sign, you got to do to that side of the equal sign. I'm going to erase this so we got some room. So, times it, boom, by the 1 liter CuSO4 5H2O solution. All right, so we got some stuff going on now. We're trying to solve for moles. We got rid of this label. Boom, we got rid of that. We're left with moles of solute here, okay? So let's go ahead and bring it down, show all the steps. You don't have to show all the steps. I do need to see setup, moles of solution. But I'm showing you how to do the steps. Now we can go ahead and times this one. But here's the deal, our labels aren't the same. And I need to show you a trick. 5H2O, we got 1 molarity CuSO4 5H2O. So looking at my labels, this is liters, this is molarity, this is moles. None of them match, okay? But I want you to watch something. If you look at our original formula, molarity equals moles of solute per liters of solution. Look at how I shortened that up. Yes? Okay, now that I've shortened that up, I'm going to go ahead and do some inputting, okay? So we know molarity, big M, equals moles per liter. I can take out this big M and put in moles per liter. Moles per liter. Okay? Now, I get to cancel liters. Yeah, cancel liters. I can't cancel the number 1. The number 1 is a number there, okay? So with that, it's all the same label. So you're left with moles. Aren't I trying to solve for moles? Yes. Okay. Now, 1 times 1 is 1. No label. Label is moles. And then of course you have your CuSO4 5H2O. Copper sulfate CuSO4 5H2O is how many moles of solute. Now, that's how many moles of solute per 1 liter. Nobody picked up a liter. Okay, so here we go. This is a liter. Nobody worked with something this size. We're gonna need to calculate it to figure out even less and even less. So that's gonna be the last end step, but I just wanna put that out there now. Now we're gonna need to figure out, because we can't measure moles in here with our electronic balances. We don't. But what we did is we took the blue crystals and we put them on electronic balances using the boat first, on the electronic balances, and we measured out grams, okay? We calculated moles, but we measured out grams. So that's where this conversion factor right here comes in. You're gonna use this conversion factor to convert moles into grams. Alrighty, so you could always pause the video, you could always take screenshots. I'm going to go ahead and erase. I'm going to keep this down here because we're going to use it. At first, the steps seem cumbersome. You may find you can get the answer without working the process. Why? Because we're working with the number 1. I mean, it's easy now, but what happens when you start working with other numbers? The key is you can't just remove labels. You can't just change it into liters just because you feel like it. You can't just change the grams into moles because that's the way it's supposed to be. You have to chase out the labels, okay? Alrighty, so we got this baby here. Actually, I probably should make it a little bit higher. Let's go ahead and make it a little bit higher so I can do some quality work. 1 mole, CuSO4 5H2O. Trust me, I fought my chemistry professors about such long labels. I finally gave in to their will. This is what we have. This is the conversion factor. Do not start with the conversion factor. You start with what you're going to be using, okay? Don't adjust the conversion factor according to what you think needs to happen. You need to adjust the conversion factor according to what is going to happen. And I don't know if that makes any sense just yet, but start with moles. We want grams. So, boom, boom, times it. So this, as you notice, has the moles on top and the grams on the bottom. We want grams on top and moles on bottom. So did I erase the wrong conversion factor? Absolutely. I should have been using this one. Go ahead and rewind your video and see. I needed the room. So I'm gonna flip it. So 249.73 grams CuSO4 5H2O are equivalent to 1 mole CuSO4 5H2O. There we go. All right, so now I'm gonna go ahead and erase this so I can get some more room. All right, all you gotta do, now I can cancel my labels. This says moles. Now remember, this is a whole number. It's equivalent to being over 1. That's redundant. So you can cancel this with this. We don't cancel the number 1. We cancel the label. It's over 1. This is a whole number. Now, 1 times this equals that. So 1 times 249.73, 249.73 grams CuSO4 5H2O. There's a new little box I like to go ahead and box up. Now, yes, it's the same because everything was times by 1, but everything is not always going to be 1. It just happened to be 1 in this lab experiment. That is why it is important to learn the process, and you will have other problem sets that won't be 1. Okay, so that's how many grams of copper you're going to put into a solution. But read back at that first highlighted stuff on page 3. The solution is a whole liter. We didn't use a whole liter. We only used 20 milliliters, right? Okay, so we're gonna put this much grams in here. I'm not gonna waste. Instead, we're gonna need to convert that into a smaller number, a smaller usable number. So, I'm gonna go ahead and erase my work here. Like I said, in our experiment, we did a 20 milliliter CuSO4 5H2O solution. And we know that this is per 1 liter. So if it's per 1 liter, then it's per 1,000 milliliters. Yeah? Because 1 liter equals 1,000 milliliters. All right, so now that we have that, let's go ahead and do some work. I'm gonna go ahead and put 249.73 grams of CuSO4 5H2O per 1,000 milliliters. And that is going to equal X amount of grams, because we don't know how many grams are going to be put in the solution. X amount of grams per 20 milliliters. Boom. Alrighty. You have 3 of the 4 variables you need to solve for X. How many grams? So whether you cross multiply or you do it the way I did it on the other one, you go ahead and do your work, see if you come back and we got the same thing. I'll go ahead and do it also. If you want to do it your way, that's fine. Okay, there's a few different ways to go ahead and do this, as long as you're not just moving decimals. That's what I'm caring about. We need to isolate this variable, so we need to get rid of this one down here. So to get rid of this one down here, you times it by milliliters CuSO4 5H2O. Remember, that's over 1. Cancel, cancel. Whatever you do to this side of the equal sign, you have to do to this side of the equal sign. All right, go ahead and boom, boom. 20 milliliters Cu. I'm gonna write solution. I'm getting lazy. I'm getting tired. All right. So with that, we are going for, what did I do? Oh, milliliters. Dang. Look at that. Milliliters, milliliters. I probably should have put the label, because otherwise I'm cheating. Copper solution, it's the same. Now, cancel the milliliters, copper solution. Cancel the milliliters, copper solution. You're left with 20, you're left with 1,000, and you finish it. So 20 times that divided by 1,000. I'm gonna go ahead and do that. So 20 times, so this is going to be the 249.73 times 20 equals 4,994.6. Hope you got the same. Oh yeah, it is. Okay. Divided by 1,000 equals 4.9946. So X grams equals 4.9946. And because of the sum of the scales we have, I told you to go ahead and put 5.0. 5.0 grams equals X amount of grams. That's how we figured out how many grams we were going to put in our copper sulfate pentahydrate solution. Okay, so this is a really long video. I'm going to go ahead and make separate videos regarding the other ones. So.